Good morning, my dear students of first secondary. Today we are going to start our first lesson in trigonometry for the second term. This lesson is called Trigonometric Identities. Let's go. Trigonometric Identities is one of the important lessons in our course. Okay, let's start. First secondary trigonometric identity lesson 1 prepared by Mr. George Milad. Basic trigonometric identities. Here we have three basic trigonometric identities. First we are going to know it together, then I will explain how we find these rules. The first important remark is we all know that sine power 2 plus cosine power 2 equals 1. We know that from the first term. Sine square plus cosine square equals 1. Okay? And from this remark we can get two rules. Sine square theta equals 1 minus cosine square theta, and cosine square theta equals 1 minus sine square theta. And the other one, it will be 1 plus cotangent square theta equals sec square theta. And from this inequality or from this identity, we can find two rules. Tan square theta, it will be equals to sec square theta minus 1, and sec square theta minus tan square theta equals 1. And the last one, it will be cotangent square theta plus 1, it will be equals to cosec square theta. Okay, and we can get that cotangent square theta will be equals cosec square theta minus 1, and cosec square theta minus cotangent square theta equals 1. Let me explain these rules for you firstly before going to the example. Okay, here is the mean rule. We have it in the first term. We have that sine, we all know that sine square x, we all know that sine square theta plus cosine square theta, and this is equals to 1. And from this equation we can find that cosine square theta, cosine square theta. Here we want to find cosine square theta. So sine square theta will go to the other side, will be equals to 1 minus sine square theta. Okay? And from this equation also we can find sine square theta. So sine square theta will be equals to 1 minus cosine square theta. So from the first rule, sine square theta plus cosine square theta, we get that cosine square theta equal 1 minus sine square theta, and sine square theta equals 1 minus cosine square theta. Okay? Let's take this rule again, and we have sine square theta plus cosine square theta equals 1. Divide all the terms by cosine square theta. We will divide all the terms by cosine square theta. Now we have sine square theta over cosine square theta plus cosine square theta over cosine square theta equal 1 over cosine square theta. We all know that sine square theta over cosine square theta, this is equals to tan square theta. Tan square theta plus cosine square theta divided cosine square theta, it will be equals to 1. 1 divided cosine square theta, we all know that 1 over cosine square theta, it will be equals to sec square theta. And this is the second rule, where in tan square theta plus 1 equal sec square theta. Here from this we can find that tan square theta will be equals to sec square theta minus 1. And we can find that sec square theta minus tan square theta, and this is equals to 1. So we have the second law that 1 plus tan square equal sec square, and from this law we can find two other laws. Tan square theta equals sec square theta minus 1, and sec square theta minus tan square theta, and it's also equals to 1. Okay, let's take the first rule again. We have sine square theta plus cosine square theta, this is equals to 1. But this time we are going to divide all the terms by sine square theta. Let's divide all the terms by sine square theta. Sine square theta, okay, divided sine square theta plus cosine square theta over sine square theta equals 1 over sine square theta. Okay, sine square theta divided by sine square theta, this is equals to 1 plus here plus cosine square theta divided sine square theta. We all know that sine square divided cosine square equals tan square, but cosine square divided sine square, it will be equals to cotan square theta. And 1 over sine square theta, we all know that 1 divided sine square, it will be equals to cosec square theta. Okay, so this is the third rule. 1 plus cotan square theta equals to cosec square theta. And from this law we can find that cotan square theta equals cosec square theta minus 1. And from this law also we can find that cosec square theta minus cotan square theta, it will be equals to also 1. Cosec square minus cotan square equals to 1. Okay, so this is the proof of the three rules we are going to use in this example. We have to memorize it very well because we will use it in solving all the coming problems. Okay, let's go. Example, write each of the following expression in the simplest form. Here we want to find or to put the following expression in the simplest form. Okay, let's go. Here solution 1 minus 1 over cosine square theta minus sine square theta over cosine square theta. This is equals to. Here we want to subtract 1 over cosine square theta minus 1 over sine square 1 minus sine square theta over cosine square theta. Here we can find that cosine square theta. Okay, here we have cosine square theta in the denominator and we have cosine square theta in the denominator. So we will take cosine square theta as a common denominator. Okay, cosine square theta will be a common denominator, and we will subtract the numerators together, so it will be 1 minus sine square theta. Okay, from the first law we know that cosine square theta plus sine square theta, and this is equals to 1. So cosine square theta will be equals to 1 minus sine square theta. So now we are going to replace 1 minus sine square theta and we will put cosine square theta. So I told you to have to memorize the rules very carefully and very good, okay? So now 1 minus sine square theta, it will be cosine square theta over cosine square theta. Cosine square theta divided by cosine square theta, it will be equals to 1. Okay, it will be equals to 1. Okay, let's go to another example. Example 2. Here we have sine pi over 2 minus theta multiplied by cosec theta. Now we want to find the value of this expression. Pi over 2 means 90. Sine 90 minus theta. Sine 90 minus theta in the first quad, and in the first quad all the trigonometric ratios are positive. But 90 changes the sign into cosine. So sine pi over 2 minus theta, this is equals to cosine theta. Cosine theta multiplied by cosec theta. Okay? We all know that cosec theta, it will be equals to cosec theta is the reciprocal of the cosine. And we all know that cosec theta will be equals to 1 over cosine theta. هنا cosine theta مع cosine theta هيروحوا فبرضه هتبقى equals to كام؟ equals to 1. Okay? So here the first example, its result equals to 1, and in the second example also the result will be equals to 1. Let's go to another example. We have many examples today. Okay? Another example. Here we want to find the value of sine theta plus cosine theta for all power of 2 minus 2 sine theta cosine theta. Okay? First, we are going to expand the bracket power of 2. Here we have a bracket to the power of 2. First, we are going to expand it. Okay? Solution. Sine theta plus cosine theta for all power of 2. First times first, it will be equals to sine square theta. First times second times 2, sine times cosine, it will be equals to sine cosine. Multiplied by 2, it will be 2 sine theta cosine theta. Okay? And the last one, cosine theta power 2, it will be cosine square theta. Okay? So this is the expanding of this bracket. Okay? Minus 2 sine theta cosine theta. This is will be equals here equal. Now we have 2 sine theta here cosine theta. Here we have 2 sine theta cosine theta, and we have negative 2 sine theta cosine theta. So 2 sine theta cosine theta will cancel negative 2 sine theta cosine theta, and the remainder will be sine square theta plus cosine square theta. And we all know that from the first rule that sine square theta plus cosine square theta, this is equals to 1 from the first rule. Okay? Let's go to another example. 1 plus 3 pi over 2 minus theta, 1 plus cotangent square 3 pi over 2 minus theta over 1 plus tan square 3 pi over 2 plus theta. Okay? Okay, solution. Here, first we are going to write this example as follows. 1 plus cotangent square 270, we all know that 3 pi over 2, this is equals to 270 minus c. Okay? 1 plus tan square, so it will be 1 plus tan square 3 pi over 2 equals to 270 minus c. Okay. 1 plus cotangent square 270 minus 270 minus. We all know that 270 minus theta lies in the third quadrant. Okay? The third quadrant, tan is positive. tan, and the cotan will be positive. But 270 changes cotan into tan, so it will be 1 plus tan square theta. Okay? Again, here in the denominator we have 1 plus tan square 270 minus theta. 1 plus 270 minus lies in the third quadrant. Okay? 270 minus دي في الثird quadrant. ارض التان يعني معنى كده ان التان والكوتان هيكونوا بوزيتيف. اوكي؟ بس انا عندي ال 270 دي شريره بتشيل الكو وتحط الكو. تمام؟ فالتان دي هتتقلب تبقى كوتان سكوير ثيتا. اوكي؟ And from the rules we know that from the rules 1 plus tan square theta this is equals to sec square theta, and 1 plus cotan square theta this is equals to cosec square theta. Okay, now we want to find the value of sec square theta over cosec square theta. Okay, we can write sec square theta in the simplest form as 1 over cosine square theta, and this is divided by cosec square theta. Cosec square theta we can write it as 1 over sine square theta. Okay, divide will change into multiplication. 1 over cosine square theta times we are going to replace, so it will be sine square theta over 1. By multiplying 1 over cosine square theta times sine square theta over 1, 1 times sine square theta هتديني هنا sine square theta. Okay, cosine square theta multiplied by 1 it will be also cosine square theta. Divide sine square theta over cosine square theta, this is will be equals to tan square theta. Okay, so this is one of the important examples here because we used many rules. The first rule, 1 plus tan square theta equals sec square theta, 1 plus cotan square theta equals cosec square theta. And we have memories from the first term. احنا هنا جبنا 270 كوتان 270 minus theta ده first term, وعندنا كمان tan square tan square 270 minus theta برضو دي احنا واخدينها في الفيرست term. And also you have to memorize that the sec its reciprocal equals 1 over cosine, and the cosec its reciprocal equals 1 over sine square. Okay, and you have to memorize that sine square over cosine square it will be equals to tan square, but cosine square divided by sine square it will be equals to cotan square. Okay, let's go to another example. Example 2. Prove the validity of the identity. Here we want to prove this relation, okay, or this identity. Okay, we want to prove that sine square theta plus cosine square theta, this is what we call it the right hand side, equals to 2 sine square theta minus 1, which is the left hand side. Okay, solution. Okay, let's start with the complicated side, right hand side. Here we have sine square theta minus cosine square theta. We want to prove that sine square theta minus cosine square theta equals 2 sine square theta minus 1. So as you can see, we have to remove cosine square theta. Here we have to remove cosine square theta. Okay, so now we are going to replace it by using the rule. We know that 1 plus, we all know that, sine square theta plus cosine square theta equals to 1. So here we have two rules. If we want to find sine square theta, it will be equals to 1 minus cosine square theta. And if we want to find cosine square theta, it will be equals to 1 minus sine square theta. So now I am going to replace cosine square theta by 1 minus sine square theta. So now this term will be sine square theta minus, we will open bracket, cosine square theta, we will replace by 1 minus sine square theta. Okay, so this is equals to sine square theta negative, we are going to distribute negative over the two terms of the bracket. Negative 1 times 1, it will be equals to negative 1. Negative 1 times negative sine square theta, it will be equals to positive sine square theta. Okay, now we have sine square theta and sine square theta. Sine square theta plus sine square theta. So it will be 2 sine square theta minus 1. And this is equals to the left hand side. Okay, I replaced the two values. This is the left hand side and this is the right hand side. I'm sorry, this is the left hand side and this is the right hand side. So it will be left hand side and here is the right hand side. Okay, let's go to another example. Here he wants you to prove the validity of the identity sine power 4 theta minus cosine power 4 theta. Sine power 4 theta minus cosine power 4 theta, and he wants you to prove that the left hand side equals to 1 minus 2 cosine square theta. Okay, this is a very important example. Let's do it together. Here, solution. Here we are going to start with the complicated side, left hand side. Here we have sine power 4 theta minus cosine power 4 theta. Here we have to factorize because sine power 4 theta minus cosine power 4 theta can be factorized into two brackets difference between two squares. Okay, يبقى هنا هنعمل difference of two squares factorization. Sine power 4 we will divide it into sine square theta and we will put here also sine square theta. Cosine power 4 theta, it will be equals to cosine square theta and cosine square theta. Okay, difference of two squares means that the first bracket is positive and the other is negative. Okay, so now we have positive and negative sign. Okay, we will write the first bracket as it is. Here we have sine square theta plus cosine square theta. We all know that sine square theta plus cosine square theta, this is rule number 1 and it will be equals to 1. Okay, so sine square theta plus cosine square theta equals 1, and it will be multiplied by sine square theta minus cosine square theta. Okay, 1 times sine square theta minus cosine square theta, it will be also equals to sine square theta minus cosine square theta. Okay, here you have to notice that the right hand side equals 1 minus 2 cosine square theta. 1 minus 2 cosine square theta. So we have to replace sine square theta by cosine square theta. طب يا مستر هنحول الساين سكوير ثيتا دي ازاي لكوزين سكوير ثيتا؟ احنا لسه قايلينها دلوقتي حالا ان ساين سكوير ثيتا equals to 1 minus cosine square theta. Okay, we all know that sine square theta as a result from the first rule, sine square theta equals 1 minus cosine square theta minus cosine square theta. This is equals to 1 minus 2. Here we are going to add negative cosine theta, and the negative cosine theta will be negative 2 cosine square theta. Okay, and this is equals to this is equals to right hand side. Okay, let's go to another example. Here we want to prove the validity of the identity sine square theta sine square theta over 1 minus cosine theta equals 1 plus cosine theta. Solution. Here we have sine square theta over 1 minus cosine theta. Sine square theta over 1 minus cosine theta. Okay? First, here we have to change sine square theta. We all know that sine square theta, this is equals to 1 minus cosine square theta over 1 minus cosine theta. Okay? Okay. Now we are going to factorize. We all know that 1 minus cosine square theta can be factorized into two brackets, difference of two squares. 1 minus cosine square theta, it will be 1 minus cosine theta multiplied by 1 plus cosine theta. Okay? Over 1 minus cosine theta. Okay. Here 1 minus cosine theta will cancel 1 minus cosine theta. So the result will be 1 plus cosine theta, and this is the right hand side. So the idea of this problem that you think you have to use your mind to know or to find a rule that join between sine square theta and 1 minus cosine theta. So first you have to replace sine square theta by 1 minus cosine square theta. And we all know that we can factorize 1 minus cosine square theta as a difference of two squares. So 1 minus cosine square theta, we can factorize it into 1 minus cosine theta multiplied by 1 plus cosine theta over 1 minus cosine theta. 1 minus cosine theta will cancel 1 minus cosine theta, so the remainder will be 1 plus cosine theta, which is the right hand side. Okay, so here we start with the left hand side, which is sine square theta over 1 minus cosine theta, and we proved that it will be equals to 1 plus cosine theta, which is the right hand side. Okay, let's go to another example. Prove the validity of tan theta plus cotangent theta equal cosec theta times sec theta equals cosec theta multiplied by sec theta. Okay? Okay. This is a very important example also. Tan theta plus cotangent theta equal cosec theta multiplied by sec theta. Okay? Here now we are going to simplify tan theta. So left hand side equals tan theta plus cotangent theta. Okay? We can write it as tan theta, we can write it as sine theta over cosine theta, and cotangent theta will be equals to cosine theta over sine theta. Okay? Here we are going to add two fractions, sine theta over cosine theta plus cosine theta over sine theta. Okay? So the common denominator will be cosine theta times sine theta. Okay? Then we are going to multiply sine square sine theta times sine theta. It will be sine square theta. And cosine theta multiplied by cosine theta, it will be cosine square theta. Okay? So in the denominator we have cosine theta sine theta. But here in the numerator we have sine square theta plus cosine square theta. And we all know that sine square theta plus cosine square theta, this is equals to 1. Okay? So now we have 1 over cosine theta multiplied by sine theta. But here the right hand side is cosec theta multiplied by sec theta. Okay? How can we change 1 over cosine theta times sine theta 2 cosec theta multiplied by sec theta. Here we can write 1 here as 1 multiplied by 1. And here we have cosine theta times sine theta. Okay? So we can separate them like 1 over cosine theta multiplied by 1 over sine theta. Okay? Because we all know that 1 times 1 it will be equals to 1. Cosine theta times sine theta it will be cosine theta sine theta. Okay. And the last thing, we all know that 1 over cosine theta it will be equals to sec theta, and 1 over sine theta it will be equals to cosec theta, which is equals to the right hand side. Okay, sec theta 1 over cosine equals sec, and 1 over sine equal cosec theta. This is the right hand side. So now we can prove that, we proved that tan theta plus cotan theta equals to sec square theta times cosec square theta. Okay? Okay, let's go to another example. Prove the validity of the identity 2 cosine square theta minus 1 equals to 1 minus tan square theta equals to 1 minus tan square theta over 1 plus tan square theta. Okay? Here we are going to start with the complicated side. Mister, which one of them is the complicated side? As you can see that the right hand side here is the complicated side. So we are going in this problem. So in this problem we are going to start with the right hand side. Okay, so right hand side equals, Mister 1 minus tan square theta دي رول. اقول لك لا دي مش رول. 1 minus tan square theta دي مش رول. امال ايه يا مستر؟ اللي تحت هي اللي رول. يعني احنا هنا عندنا 1 plus tan square theta. This is a rule. We all know that 1 plus tan square theta this is equals to sec square theta. Okay? 1 plus tan square theta equal sec square theta. So we are going to replace 1 plus tan square theta by sec square theta. Okay, Mr. طب what about the numerator? The numerator we will replace by here 1 and tan square theta. We all know that tan square theta equal sine square theta over cosine square theta. And this is equals to, we can write the right hand side as 1 minus sine square theta over cosine square theta. Okay, this is the numerator divided by sec square theta. Here we can write sec square theta as 1 over cosine square theta. طبعا انت كده هتلاحظ ان انا كل ما بحاول او كل ما بتزنق في المسألة برجع كل حاجة لساين ثيتا وكوزاين ثيتا. يعني لو لقيت كوسيك I replace it to cosine 1 over cosine. If I find sec I will replace it by 1 over cosine. If I find cosec I replace it by 1 over sine. And if I find tan square and the tan square is not one of the rule, so I replace tan by sine square over cosine square. Okay? Now here we are going to put this in the simplest form. Here we want to subtract 1 minus sine square theta over cosine square theta. Okay? Here we can write 1 here as cosine square theta over cosine square theta, because we all know that cosine square theta over cosine square theta this is equals to 1 minus sine square theta over cosine square theta. This is a good trick. Okay, this is a very good trick. Why? Now we have cosine square theta, as we can take cosine square theta as a common denominator, so it will be cosine square theta. Okay, and now it will be cosine square theta minus sine square theta. Okay, this is divided by 1 over cosine square theta. Okay, this is divided by 1 over cosine square theta. We'll change the divided into multiplying, and this is equals to cosine square theta over 1. Okay, by multiplying you can find that cosine square theta will cancel cosine square theta, so the result will be cosine square theta minus sine square theta over 1. This is equals to cosine square theta minus sine square theta. Very good. Now here look to the left hand side. We want to prove that the right hand side equals to 2 cosine square theta minus 1. 2 cosine square theta minus 1. Okay, so we have to get rid of sine square theta. How can we do it? By replacing this is cosine square theta minus. We all know that now. We know that sine square theta equals 1 minus cosine square theta. Okay, so now distribute the negative sign. Cosine square theta minus 1 plus cosine square theta. So the result will be cosine square theta plus cosine square theta. It will be equals to 2 cosine square theta minus 1. So this is equals to the left hand side. Okay, so the problem is getting harder and you have to concentrate more. Okay, let's go to another example. Here in example 7, he wants you to prove that sec square theta minus tan square theta multiplied by sine square theta, all of this will be equals to cosine square theta minus sine square theta. Okay? Okay. In this example, here we have left hand side and we have right hand side. So solution. Master, we are going to start with the left hand side, and this is equals to sec square theta minus tan square theta multiplied by sine square theta. Okay. First, we are going to replace sec square theta by 1 over cosine square theta. Okay, minus tan square theta, tan square theta. We can write it as sine square theta over cosine square theta. Okay, this is multiplied by sine square theta. Okay. So now we have 1 over cosine square theta minus, are going to multiply, we can put sine square theta over 1, so we can multiply sine square theta multiplied by sine square theta, it will be sine power 4 theta over cosine square theta. Now we can take cosine square theta as a common denominator. يبقى cosine square theta as a common denominator equals here 1 minus sine power 4 theta. Okay, okay, 1 minus sine power 4 theta, we can factorize it as a difference of two squares, so we can write it as 1 minus sine square theta multiplied by 1 plus cosine square theta. And we can replace cosine square theta by 1 minus sine square theta. We all know that cosine square theta equals 1 minus sine square theta. Perfect. Now we can cancel 1 minus sine square theta and 1 minus sine square theta. So the result will be 1 plus cosine square theta. Okay. Okay. But in this example, we want to prove that 1 plus cosine square theta equals cosine square theta plus 2 sine square theta. Okay? Here we want to prove that. Sorry, here this is here واحنا بنعمل factorization هنا 1 minus sine power 4 theta, it will be 1 minus sine square theta and 1 plus, I'm sorry, 1 plus sine square theta. So it will be, okay, I will erase it for you. So it will be here, it will be 1 plus sine square theta. So now we have the result will be 1, the result will be 1 plus sine square theta. It is not 1 plus cosine square theta. So here the result will be 1 plus sine square theta. Okay, so this is equals to 1 plus sine square theta. Okay? Okay. Now we all know that we want to prove that 1 plus sine square theta equals cosine square theta plus 2 sine square theta. How can we do it? How can we change 1 plus sine square theta into cosine square theta plus 2 sine square theta? Here we can write this one as sine square theta plus cosine square theta. Oh, yes, we can write 1 as sine square theta plus cosine square theta, and here this is plus sine square theta. So it will be here sine square theta plus sine square theta, it will be 2 sine square theta, and here will be cosine square theta plus sine square theta plus sine square theta. This is equals to sine square theta. Okay, so this is the right hand side. So the left hand side equals to the right hand side. Okay, let's go to the last example. Here, this is one of the important examples and a different example from the previous. Here, if sine theta plus sine 270 minus theta equal half, find the value of sine theta cosine theta where theta belongs to open interval 0 and pi over 2. Okay? Okay. This is a different idea. Solution. Here we have sine theta plus sine 270 minus theta. This is equals to half. Okay? Okay, let's concentrate on this part. Sine 270 minus theta. 270 minus lies in the third quadrant. The third quadrant is here in the third quadrant we have 10 is positive, but in this quadrant sine is negative. Okay, the sign here is negative. So now sine theta will left over here 270 minus in the third quad, tan and cotan are positive, sine is negative, so we will put negative sign. 270 will change the sign into cosine, so it will change into negative cosine theta. So now we have sine theta minus cosine theta equals half. By squaring, in this example we have to square the both sides by squaring the both sides. Okay, so this is will be sine theta minus cosine theta for all power of 2, and this is equals to half for all power of 2. Okay, expand the brackets, it will be sine square theta plus cosine square theta minus 2 sine theta cosine theta. Okay, and this is equals to half power 2, it will be equals to 1 over 4. Okay, you can see that I put the sine square plus cosine square next to each other because I know that sine square theta plus cosine square theta, it will be equals to 1. 1 minus 2 sine theta cosine theta, and this is equals to 1 over 4. Okay, let's replace 2 cosine theta sine theta will go to the other side, and 1 over 4 will go to the other side. So now we have 2 sine theta cosine theta, it will be equals to 1 minus 1 over 4. 1 minus 1 over 4. So 2 sine theta cosine theta, it will be equals to 1 minus 1 over 4, it will be equals to 3 over 4. So the wanted value, which is sine theta cosine theta, divide both sides by 2, so it will be equals to 3 over 8. Okay, thank you so much. Until we meet again next time, goodbye and good luck, and take care of this lesson. This is a very, very important lesson. Thank you so much. Until we meet again next time, goodbye and good luck.